let's go through these. For number 1, you need to find the intercepts. I know we did that a couple units ago. So I'm going to start off as the extended version. Remember, for the intercepts, you need to put 0 in for one of the variables, which gives you 0. And then you could really just skip to 4y equals 12, divide both sides by 4. So y equals 3. But you should be putting those in ordered pairs. And then you could do the same thing for the other one. I'm going to skip through some of this. So instead of doing these steps, I'm going to skip to this step and just say negative 2x equals 12. And divide both sides by negative 2. So that would be the ordered pair negative 0, negative 6, 0. If you solve this equation for y and found the y-intercept that way, you could do that. But I wouldn't do that for the x-intercept. You would need to put 0 in for y and solve for it that way. Questions on number 1? For number 2, you were given some f of a number where you had to evaluate using function notation. So put in negative 1/3 every time you see an x. So this would be negative 1/3 squared plus 3 times negative 1/3 minus 2. So this would give us negative 1/3 squared would be 1/9. 3 times negative 1/3 would be minus 1 or negative 1. And then the negative 2 would get brought down. So I have 1/9 minus 3. And you're going to need to change 3 to be a fraction over 9. We would get negative 26 over 9, which looks like it would simplify, but I don't think it does. So our final answer would be f of negative 1/3 equals negative 26 over 9, or f of x equals negative 26 over 9. Have any questions on number 2? Number 3, you just needed to simplify, distribute the 7 to get 7x plus 14 plus 5x. Then combine your like terms to get 12x plus 14. On the back, we needed to solve number 4 completely. So distribute twice. We have 32x minus 16 minus x plus 10 equals 15x plus 10. Combine your like terms. That will give us 31x and negative 6. Looking at just this, I can tell that we're going to have one solution because the constants aren't the same. neither are the coefficients. And then we can pick whatever we want to move. Let's say we move the 15x first. And then added 6 to both sides. So we have 16x equals 16. Divide both sides by 16 and we get 1. Questions on number 4? And then for our last one, we needed to graph this equation starting at our y-intercept of positive 1. And then our slope is negative 3, so we should be going up 3 to the left 1 as many times as possible. And then down 3 to the right 1 as many times as possible. Draw a line through that point, those points, and make sure you have arrows. Questions on either of those two? You should have these notes on your desk, the substitution method. This is going to be the second way we solve systems of equations. There are 3 methods in all, and we'll talk about the next one on Friday. And then when we talk about word problems, you'll have 3 different methods to solve them. First, I don't remember exactly what this is. So let's do this. Substitution method is a method of solving systems of equations by substituting equations within one another. The steps for solving using substitution method are as follows. Solve one equation for x or y. Substitute the expression into the other equation and solve for the variable. Substitute your answer into the revised equation from step 1, but that's kind of optional. It doesn't have to be from that exact equation. And then solve for the other variable. So it's a lot of solve, substitute, solve, substitute, solve. We're going to do the first 6 problems together, then I'm going to let you guys try the last 5. Yes.
This is what the Khan Academy is from.
This is the 3rd Khan Academy.
we allowed to use Desmos for the same time?
Yes. So you can definitely still use Desmos. I would say definitely still practice solving substitution, but yes, you can still use Desmos. As well as on the test, you'll still be able to use Desmos, but I'll need to be able to see the substitution or elimination as well. Because I said this but didn't check for this before we continue. Did anyone have questions about the graphing Delta Math or Khan Academies before we continue? Alright, so let's go through some of these problems. Starting with number 1. First, look and see, do we have an equation that solves for x or for y? Yes. We actually have 2 of them. In this case, because we have 2 of them, we could do one of 2 things. We can either take this equation or this expression from the first equation and substitute it in for this y, or we could take this expression from the second equation and substitute it into the first, where that y is. Either way you do this, you're going to have one part equal to another part. So whether you put this on this side or this on this side, that part does not matter, but we're taking one equation and putting it into the other. And either way we do that, they end up equaling each other. Without solving this, what type of solution are we going to get? 1. So keep that in mind. So now we can start solving this. What do we want to move first?
2x.
Okay. So we can subtract 2x on both sides. Now we have 2x minus 1 equals negative 5. Because we moved the 2x, we now need to move the 1 by adding it. And then solve for x so that x equals negative 2. So we substituted it into another. We didn't need to solve for x or y because it was already solved. We substituted it into the other. We solved for one of the variables. Now we're going to take this number that we found and we're going to put it back into either one of these. It does not matter which one. You don't need to do both. I'm going to show you that both work, but you just need to pick one. Did not do that right. That makes sense. I'm sorry. If you want to set at 10 instead of 12, I think you can do better from this. There we go. Now we're in that. It wasn't going to match. So just as one of those is yours, the other one is not. Just as we were graphing, the answer choices could be an ordered pair, no solution, infinitely many. This is the same thing. So when we find one solution, we have to write it as an ordered pair. Before we continue on, does anyone have any questions on how we did any of that process, how we got the answer, any of those things? Sabina.
So why would we have to do both equations?
You don't. I was just showing you that they both work.
I know I'm saying why would
Because in this case, you're just trying to find the value of y. You're not trying to see does it work. So you're not trying to test the solution. You're just trying to figure out the part of the solution. That's why we don't have to do it. Now, if you wanted to check this, the -2, -9, then you would need to put it back into both and make sure it works. Right. Let's move on to number 2. Do we have an equation where we have x or y solved by itself? Yes, this one. So we're going to take this expression from this equation and we're going to substitute it into the other one where y is. The only reason this one is different than the first one because they were both already solved for y, so we had to set them equal to each other. So think about this like evaluating. If this were y equals 6, we could put it in for y and find x. Same thing. We're taking the equation or expression and putting it in for y so we can find x and then find y. So when we do this, we're going to rewrite this equation. 2x plus 3 times whatever y was, which was 6x, equals -20. When you do this, what you should notice is whatever you substitute in has the same variable that's already there. So you only are left with one variable, like here we only have x. If you substitute something in and you still have an x and a y, something's wrong. So go back, double check that you didn't substitute into the wrong thing. Because had I put this in for x by accident, I'd have an x and a y. Right, from here we can start solving. So this would be 2x plus 18x equals -20. Combine your like terms. And solve for x. Once you've solved for x, you can really put this back into either one of these equations and solve for y. But if there's one already solved for y, choose that one because it'll be easier. Not that you can't use this one, you just have to solve it a little bit more. So since this one's already solved, I'm going to say y equals 6 times -1. So y equals -6. And then my order pair would be -1, -6.
How do you get one? Sorry.
How did I get what?
Why?
Like how did I get this part?
Yeah.
I just looked at this equation. The one they gave me.
Okay.
Yes, Sabina. Yeah. Any other questions on how we solved that, got that answer, that process? We're going to move on to number 3, and 3 is going to be very similar to what we just did in 2. Do we have an equation that solves for x or y already? The first one. So that means we're going to take this expression and we're going to put it in for y in the second one. So we can rewrite this second equation with the first one in it. So 3x plus 8. Use parentheses anytime you put another expression into it. I meant to say that earlier. x plus 9 equals negative 5. I only have one variable, so I know I substituted correctly. And then I can start solving. 3x plus 8x plus 72 equals negative 5. Combine your like terms to get 11x plus 72. Subtract 72 to the other side. And divide both sides by 11. So x equals negative 7. And then we could go back and find y. I'm going to use this equation since it's solved for y already, but if you wanted to use the second one, you could do that. Either. It doesn't matter. I think it does matter. So here we get y equals 2. So our ordered pair would be negative 7, 2. Javier, make sure you're writing this down. Questions on that one? So far we haven't seen an example where it's no solution or infinitely many solutions. But if that were the case, when we go to combine the terms, the variables would cancel, so you wouldn't even have a chance to keep solving. You would know that very early on. I don't know if one of the ones I chose is that or not. Okay. Number 4, do we have an x or a y solved by itself already?
The first one.
The first one is x now instead of y. That's fine. It doesn't have to be y. It could be either or. The process is going to be the same, except now when we substitute this into the other one, we're putting it in for x instead of y. So this would be somewhere where you need to make sure that you're not putting it into the wrong thing. Because maybe if you saw a lot of y's and you were putting those in for y, and then confused this and did the same thing, then you end up with this, 2 different variables. So when we rewrite the second one, we have 2 times whatever x was, so 4y plus 7, minus 6y equals 12. And then the rest of that process is the same. But now we're going to solve for y first, and then have to go back and find x. This would be 8y plus 14 minus 6y equals 12. I could combine my like terms. 8y minus 6y gives me 2y. Subtract 14 on both sides to get 2y equals negative 2. And divide both sides by 2. Now that we have our y, we can go back and find x. And because we have an x equals already, I'm going to put it back into this first one. So x equals 4 times negative 1 plus 7. And then go from there. This would give me negative 4 plus 7, so this would be positive 3. Remember that that we solve for y first. So when we write our order pair, you have to switch it in the order you found. So 3, -1. As our final answer. So far, if this is making sense, give me a thumbs up. If it's kind of making sense, thumbs sideways. If it's not making sense, thumbs down. Number 5, do we have an equation that solves for x or y by itself already? No. So that means we have to solve for x or y before we do anything else. It doesn't matter which x or y you solve for, but I'll say the easiest one is the one that's by itself. So if you look for one that's by itself, or almost by itself, let's say it has a negative in front, that would be almost by itself because that's easily solved for. So a positive or a negative variable by itself, or has a coefficient of 1 or -1, would be the one that would be easiest to solve for. If you solve for anything else, you're going to end up with a bunch of fractions. So just be careful. It can be done, but be careful. So to solve for this equation, what will we do to get y by itself?
Subtract x.
Subtract the 2x on both sides. And I'm going to go ahead and switch these two. So we have y equals -2x minus 2. So these ones will have like one additional step. Now we have an equation that's y equals. Now we can take that and substitute it into the other one where y is. So this would be, when we rewrite it, 5x plus 3 times -2x minus 2 equals -8. From there, we could solve it. So 5x minus 6x minus 6 equals -8. When we combine our like terms, this would give us -x minus 6 equals -8. Add 6 to the other side. So we have -x equals -2. And divide both sides by -1. Now that we found x, we can go back and find y. By putting that in. So this would be y equals -2 times 2 minus 2. That's a lot of 2's. So -4 minus 2 or -6. So our final answer would be 2, -6. Very last one we're going to do together is 6, but I want you guys to walk me through how would we solve this. I heard solve one of them and
Y-intercept.
turn it into a y-intercept. Saeed, you were going to say something?
You should do the one with 2x plus y because it has a variable x.
Okay. So then what do I do from there? Are you going to say something?
Just minus 2x on both sides.
So I have y equals,
2x plus 9.
okay. And then what?
then you take that and put it into your y in the other equation.
How exactly would I do that?
You would put 2x minus 3 times negative 2x plus 5 equals negative 1.
From there, what would I do?
You distribute negative 3.
So this would give me. What would I get after that?
Um, 2x plus 6 equals negative 27. Equals negative 11.
Okay, and then from there, which is
8.
okay, then from there,
Subtract negative 27.
So
Or add
that
27.
add 27.
Both sides.
Okay. And we would get
16.
okay, then what? Divide by 8. And we would get
2.
Then we take x equals 2 and then put it into y equals negative 2. And just like, so you put like y equals negative 2 times 2 plus 1.
and that would give us negative 4 plus 9, 5, yes. Two. Do you have any questions on how to solve systems of equations by substitution? Three. Any other questions, concerns, any confusions you want to clear up? Alright, so as I mentioned before, we were going to do the first 6 together, and then I want you to try the last 5. So 7 through 11, I want you guys to try. And then we'll come back and we'll talk about them and go over them. I'll check in 10 minutes and see where everyone is. If we need longer or more time, then that's fine. Really, I'm just going to say what the answers are, and then if we need to double check the work or anything like that, we can go back to that. So for number 7, you should have got that was no solution because they ended up being parallel lines. The variables canceled. For 8, the solution was 8, negative 2. For 9, those should have been infinitely many solutions because they ended up being the same line. So had you solved both of these, you would have solved that they were exactly the same. 10 was negative 2, 0. And 11 was negative 1, 5. Again, if you didn't get those, make sure you go back and you check them. If you didn't try those, you should be trying them and not just writing down the answer, because the only way to get better at math is to practice it. Anyone have any questions on any of those? Alright, so for the remainder of the class, here are the following things that you can be working on. If you didn't do the Khan Academies or Delta Math for systems of graphing, you can work on those. If you've done those already, you can work on the Delta Math and Khan Academy for systems by substitution. If you finished those already, what I mentioned earlier, the practice problems in the solving systems by graphing that we didn't do or go over, you can work on those. If you're done with all of those things, then you can work on other work, but you should be working on those things first. Anyone have any questions on what we're doing for the remainder of class? You guys have this time to work. Let me know if you have any questions.